Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on February 26, 2026, about 8 days ago. It introduces an open infrastructure that helps AI agents systematically accumulate knowledge, improving average rewards by 40% and reducing execution steps by 30% across multiple models. The paper is titled, SkillNet, Create, Evaluate, and Connect AI Skills. And as we'll see later, the framework shows some really impressive results, with significant implications for helping agents move from transient experience to durable mastery. And for those interested in the implementation, the authors have shared their code on GitHub. Alright, Figure 1 gives a high-level overview of the SkillNet infrastructure. It organizes over 200,000 agent skills into a structured network, which connects different functional categories, like development and science, to specific capabilities. To make sure these skills are reliable, they are evaluated across 5 key dimensions, including safety, executability, and cost awareness. This structured setup is what allows agents to reuse knowledge effectively, so they avoid starting from scratch on every new task. Okay, diving into the details, Figure 2 walks us through the end-to-end pipeline for building these skills. The process starts on the left by gathering diverse inputs, like user trajectories, GitHub repositories, and direct prompts. These feed into a creation module that extracts reusable capabilities. Then, in the filtering stage, the generated skills are rigorously graded across the 5 evaluation dimensions we touched on just now, to ensure only safe and complete skills move forward. Finally, the approved skills join the structured network, creating a shared repository where users can search, download, and contribute. So, Figure 2 just walked us through the creation pipeline. Now, Figure 3 breaks down the skill ontology, which is a structured map showing how skills are organized into a composable network, meaning they can be combined like building blocks. At the top level, the skill taxonomy categorizes broad domains down into specific functional tags. Then, the middle layer is the skill relation graph, where those tags become concrete skills and connections show how they interact or depend on each other. Finally, the bottom layer is the skill package library, which bundles individual skills together into task-oriented packages for easy deployment. Well, since Figure 3 mapped out how skills are organized, Figure 4 focuses on quality and reliability. The left bar chart breaks down the curated skills across 5 dimensions. Most score good or average, though executability proves to be the most challenging, with a larger chunk rated as average. The right heat map then confirms that the automated evaluation is highly reliable. Compared to human experts, the model achieves a near-perfect agreement score, or quadratic weighted kappa, of 1 across all dimensions, proving it can reliably manage the growing repository. Okay. After Figure 4 showed the reliability of the skills, Table 1 presents the actual performance gains across 3 simulation environments, AlfWorld, WebShop, and Science World. The table compares baseline methods against those augmented with SkillNet, using 3 different backbone models, like DeepSeek v3.2 and Gemini 2.5 Pro. We see that integrating SkillNet consistently boosts the average reward, marked as R, while simultaneously dropping the average number of steps, marked as S. These improvements hold strong, whether the models face seen or unseen tasks, proving that the structured skills help agents generalize better and solve problems more efficiently. So, Table 1 highlighted the strong performance gains, and Table 2 now compares SkillNet against existing platforms. We can see that alternatives like ClawHub or SkillsMP mostly act as simple catalogs that do not support automated creation. SkillNet instead serves as a full lifecycle infrastructure, using large language models to generate skills from user trajectories. It also evaluates them across multiple dimensions, rather than relying on basic community ratings. Finally, at the bottom, SkillNet boasts over 250,000 total skills, highlighting its massive scale. Alright, wrapping up, the main takeaway is that SkillNet allows AI agents to move from isolated, transient experiences to durable mastery. By formalizing skills as composable assets, it sets a strong foundation for self-evolving agents that can continuously accumulate knowledge. That is it for this episode of the AI Research Roundup. I am Alex, thanks for listening.